because I still do have a company to run, and I still am an engineer, and I still lead projects, and I've got clients to serve. So Zach would try to funnel that to us, but that wasn't really working that well because there was just so much to go through. So then we decided we needed to add another person that could help filter through all those questions. So one of the ideas that came through was, hey, let's do a live stream, get everybody on, and they can ask questions live, and we can just answer them quickly. But to do that, we're going to pick 5 questions from some of our YouTube videos. The other thing is Vaughn, you guys might be familiar with a guy named John McLeod, who is our director of sales. He's also he's recently been promoted to our chief experience officer. So John has a role on the board of directors at IIoT Integration and our other companies. Vaughn works with John. So Vaughn reports directly to John. And so John's still with the company. He's still managing accounts, but Vaughn has been a new addition who's now also in charge of marketing. John McLeod, who is our director. So I assume it's streaming just fine, Zach, right?
Yeah, it's coming in good. Yeah, I opened up the tab there and it started playing for a second.
All right, so what have we been doing? Okay, so we've been very busy. We've been incredibly busy. A lot of people have reached out, hey man, how's business going? Yada, yada, yada. The answer is we've actually shattered our sales records for the year. I mean, we're in July and we've already broken our sales record for our whole company. What basically has happened is, as a function of this pandemic, manufacturers have basically all realized overnight, wow, we're behind the 8 ball. And so a lot of people have been reaching out to us for help with digital transformation. And we have been trying to help as many as we can. We've grown the team. We've added several new engineers. We're actually getting ready to interview another solutions architect to bring into the team. We are very selective about who we bring onto the team. So it takes us a while to make a decision about who's going to come join us. We're balls to the wall project wise. Some really exciting stuff that's been going on at Intellic. There are 2 projects that we've been working on, multi-year engagements with like mid-level manufacturers. So one of them is in the oil and gas industry, and one of them is in discrete manufacturing, specifically food and beverage. And there are 2 clients that basically gave our company complete control over digitally transforming their businesses. So that is, there wasn't a team internally we weren't having to deal with the client politics, which we're gonna discuss in another video, how internal infighting within an organization can derail your digital transformation efforts. So these are 2 clients where we didn't have that. Basically, we had the ear of the people who are making all the decisions, the owners of the company, the board of directors, and basically they turned over digital transformation to us completely. So their whole goal was, you guys are the doctors, you fix us. And so we, as opposed to doing like the project model where they give you a list of requirements, we actually created the requirements. We actually came in and said, this is what digital transformation looks like. This is what your business is going to need. And we built it. And both of those projects are coming to the end of one of them's like in phase 17, phase 16, something crazy. And the other one is like phase 20. And we're ramping down, and now we're getting ready to convert these unified namespaces and these manufacturing infrastructure. So whether that's SCADA, MES, whether that's the ERP integration, to machine learning and AI. So those are a couple of really, really exciting things that are happening at Intellic. Awesome. Where we are going to be able to present to the world what the plant of the future looks like. Awesome. And here is what's capable. So go ahead, Zach.
Yeah, that's something that everyone has really been asking for. And I'm really excited to get into that. But I just wanted to make sure to remind everyone to hit the like button if you guys are in this chat right now. It really helps get the message out, and possibly share this out on social media. And yeah, we're going to get right into your guys' questions. Just thank you everyone for joining. It's really good that you guys are here. It's glad to see you guys in the chat. And thank you again.
So one of the questions that's been is, why have we not been shooting content? The answer is it's twofold. Number one, we've been incredibly busy. Our all of our engineering staff, we're all been buried. We've also been moving to purely remote work. We already worked remotely all the time, especially the engineering staff, but we have offices all over the country that we have been transitioning and closing those offices. So we still have our corporate headquarters here in Dallas, but I have not been in our office in Dallas since like the end of February, something like that. So there are people who have been going there, but we've sort of discovered that, hey, working remote maybe needs to be what we do permanently. So the other issue is Zach can't fly. One of the things when we shoot content, one of the ways that we do this is Zach stands behind the camera and he speaks for you. One of the reasons I love having Zach shoot our media is Zach speaks the language. He is an engineer. He is a software developer, and he happens to be a damn good one at that. I mean, he's an elite level developer. So he gets to speak for you. And that is one of the huge advantages I have. He asks the questions that you guys would be asking. And right now he can't fly. And so we're still trying to figure out how can we shoot content and still have that interaction so that the content is the stuff that you guys want to see. So today is the first time that we're actually going to try and shoot. Basically, I'm setting the camera up. I'm going to be recording everything. And Zach is going to be on a laptop talking as if he's in the room. We're going to try that today and let's see how it goes. But the other way is we're coming up with ideas so that we can engage with the audience.
Yeah. And let us know if this might be something that you guys would want to see like on a monthly basis where, I know you guys ask a lot of comments in our YouTube videos, and, it would kind of incentivize you guys to leave comments on those videos, knowing that maybe once a month, Walker is going to jump on live and answer like the best 5 or so comments from those YouTube videos, like in video.
So
let us know if you guys want that.
I would love to do this. The only reason we haven't done this live stream is I just haven't thought that people would come on. So I haven't really approved it up until this point. A couple of things we're talking about creating a Discord server so that we can be in touch with the community in real time, 24 hours a day, 7 days a week. Number one. Number two, we have been we've been working on the mentorship program. So the pandemic really screwed everything up with the mentorship program because we still have to shoot most of the content. And so we have the response has been overwhelming. It's been crazy, the number of people who want to join the mentorship program. Basically, for those of you that don't know what it is, we're basically going to offer you the training that we use for all of our engineers. You're basically going to go through the exact same training that anyone who comes to Intellic goes through. But then there's going to be some additional training on top of that, which is going to be more specialized to people who are still used to doing Industry 3.0 types of integration. So with that, that's the quick update. That's the 10-minute update. I can't believe I got it in 10 minutes. And we're going to do questions. I really would like to answer questions live. So I'm going to go through these 5 questions that we have from the YouTube channel. And if you guys have any questions that you want to have answered specifically, I do want to answer them live. So please type your questions in because I would love to answer them in real time with you. Okay. All right. So I'm going to share my screen real quick. You need to let me share, Zaki.
Oh. All right. I'm going to make you a co-host.
Okay.
That should do it.
That does it. Okay. All right. So for you guys, in our channel comments, I actually went, if you look at our YouTube channel, I mean, there's, thousands and thousands of comments that we have not answered. So what we did today was we went through and we looked at a lot of the key questions. A lot of them were related to SCADA and DCS, which I'm going to cover in depth here in a second. But anyway, this is what we're going to be responding to. So DCS versus SCADA versus PLC. So one of the key questions that keeps coming up is I get it. DCS, SCADA, PLC, what's actually the difference? And there were lots of questions over here related to this. So if I go, if you look at the one that I like is SCADA's main things of controls and alarming. Thank you. Now I understand PLC, SCADA, and DCS a little bit better. Can you help me understand the difference a little bit better? So I'm going to go ahead and explain a couple of elements of SCADA PLC versus DCS. Okay. So on the left-hand side here, I created a nice little chart, nice and pretty. This is the architecture that most of you should be used to, right? You have sensors and field devices in the field. You've got sensors, you got motors, you got virtual frequency drives, you got flow control valves, you got all that stuff, right? They connect to a PLC. You know, most of you guys are probably working with either Siemens S7 models or Allen Bradley control logics or compact logics. They have I/O cards where the sensors input into the I/O cards, the output card outputs to your motor or your drive, and then you have a CPU running in the PLC that's running a program that is looking at the inputs and firing the outputs based on certain conditions. That's your automation, right? The way that the PLC generally talks to the outside world is not directly. It talks to an OPC server. So this would be something like Kepware in the middle. It could be a DAS ABC IP from Aviva. It could be Matricon OPC. There's lots of pieces of software that talk to this PLC. And it would talk to this PLC, this one specifically, if it's a compact logics, through an Allen Bradley communications driver. And then all the software that wants to get the data from the edge, from the PLC, is going to get it through that OPC server. So you're going to also add in some third-party SCADA software. So this would be like Wonderware, this would be iFix, this would be Ignition, Factory Studio, all those things talks to the OPC server, okay? When you install Wonderware, or when you install Ignition, or when you install any of the third-party SCADA platforms, they are blank. That is, all you have is a canvas to create a SCADA application. What SCADA is supervisory control and data acquisition. It's where you manage a plant remotely, okay? It's not, SCADA is HMI on steroids. HMI is generally unique to a specific process or a particular line. SCADA kind of aggregates all that together into one interface where you're managing all of your alarms. I can look at all of my alarm banners for the whole plant or my whole area. I can control the process. I can turn the process on, I can turn the process off, I can adjust set points from that SCADA software. But when that SCADA software gets installed, it's blank. It's just a canvas, it's just an IDE. When the OPC server gets installed, it is blank. There are no channels or devices or tags configured. You have to engineer there. When that PLC gets installed, it is empty. You have to, most of the time, update the firmware running on the PLC. You got to configure each of these individual cards, and then you have to write your ladder logic or your sequential function chart or your function blocks to do your automation. All of this, think of it as off the shelf, right? It's like buying the wood. It's like buying the nails, and then you go in and hammer everything together, okay? On the right-hand side, what I have is DCS, okay? So this is the comparison to SCADA, this PLC SCADA structure, okay? One thing I want to point out, this PLC connects to this OPC server over like Ethernet IP. It's an Ethernet network. And this third-party SCADA software also connects to the OPC software over like Ethernet IP. So it's like an open, regular Ethernet IP network. This is DCS, okay? So one of the things you have to understand about DCS is that distributed control systems care about two things above all else. They care about security and they care about speed, okay? You're gonna see a distributed control system in processes that generally are super, super, super fast. So like, you're never gonna go into a steel mill that has a rolling mill that takes billets and reduces them down into rebar. You'll never see that being run by a standard PLC that just some engineer wrote a program on. It's too dangerous. It has to respond too fast, okay? You use a distributed control system because in a distributed control system, you have a controller. That controller has input and output cards, okay? This controller rack, this is the brains of the system. It has an input cards, it has output cards, it talks to sensors and field devices, just like a PLC does. The difference is most of the time the DCS has pre-configured blocks inside of the DCS system. Not all DCS systems have this, but most do, have pre-controlled blocks inside the system that are specific to certain processes. So say I have a tank object, or I have a rolling mill stand in a steel mill. There are many DCS systems, ABB specifically, has objects inside of the controller that are designed specifically for certain rolling mill stands. Go ahead, Zach. You're on mute.
This is why some would say that plant packs for Rockwell's automations line of PLCs makes it DCS-like, because they give you those pre-configured objects that map to their SCADA, that map to their PLC, that map to the real object, and you have that functionality like a DCS.
Which is exactly what Rockwell was trying to accomplish when they created plant packs. Okay, that's exactly what they're trying to accomplish. But the thing, I'm going to get to the thing that Rockwell was missing. Okay, and that is Rockwell doesn't use a field bus to talk across from PLC to PLC. Now they can, you could put field bus modules in, but that's not how they talk. Okay, so I've got my DCS controller, but I also have DCS remote IO. I can have remote IO over here, remote IO over here for my PLC. I can have a PLC talk to a remote IO rack, but it's generally going to do that over Ethernet IP. It's going to talk to the other rack through Ethernet. This DCS controller in most DCS systems, actually, basically every DCS system, is speaking to the DCS RIO, the remote IO, over field bus, which is blistering fast. Okay, so imagine I've got a printing press where I've got a bunch of printing stands and they are all operating at 1,000 feet per minute. Okay, and they're printing very detailed images onto paper. Okay, to get that register correct, that is to get it so that the inks all line up correctly and it prints what it's supposed to print on the page. All of those stands have to work in unison very quickly, super fast. So fast that you can't do it over a non-field bus network. Okay, so DCS is super fast. Oh, the DCS controller always talks to the RIOs over field bus, which can process transactions sometimes as fast as 3 to 5 milliseconds. Okay, in Ethernet IP, you would never reliably expect a response faster than 25 milliseconds over Ethernet IP, for example. The last piece, there's no OPC server between the DCS controller and the native DCS SCADA. So nearly all SCADA systems, DCS systems, come with their own SCADA software. So whether I'm dealing with Delta V or whether I'm dealing with like an ABB DCS, they have their own software packages which are designed for the objects, the pre-configured objects in the DCS system. But the controller talks to the SCADA system over the field bus network as well. So that means the SCADA software can control what's happening in the distributed control system much faster. When I make a change to a set point, it happens much faster than it does when I'm using third-party SCADA OPC server to PLC. Okay. So there was a question that was asked about, you said DCS systems are turnkey. What I meant to say is that DCS systems are used much more frequently in turnkey solutions. So that is, I'm building a brand new steel rolling mill. I'm building a brand new printing facility. And part of that implementation is installing a new DCS system to control it. That is a turnkey solution. I don't buy a rolling mill stand and then buy a separate PLC to run it with an OPC server and build a separate SCADA system like we do in lots of other discrete manufacturing processes. Okay, so that's the fundamental difference. Okay, DCS is all. Go ahead, Zach.
I was going to say, after you finish, if you wanted to explain, because most people, like, they're either in one world or the other, but it's interesting how you have been able to gather PLC and DCS experience. You talked about the arc of your career. If you wanted to touch on that.
Yeah, that's the next question, actually. So I'll touch on that in the very next question, which is, a lot of people have asked this. Hey, I love IIoT. I love Industry 4.0. What do I need to study so that I can do it? I'm going to talk about that next. Okay. I hope that clears up the DCS versus SCADA versus PLC thing. Distributed control systems there is a lot more of this on the left-hand side than there is on the right-hand side. You see the left-hand side architecture, the PLC to OPC server to SCADA to MES, much more than DCS. And one of the things that we're discovering is the people who have the DCS systems are having a lot more trouble digitally transforming, which is ironic considering that DCS systems are the one that generally come with the native objects running on the edge. Okay, and if we wanted to do object-oriented IoT implementations, should be much easier, right? All right, so that's answer to question number one. Question number two, what do I study to be an IIoT integrator? So this was asked by Taylor Beamer, and this was I think this was in the oil and gas, the oil and gas IIoT example. He said, this is exactly what I want to learn from. For someone with an instrumentation and controls background, what's the best way to learn the networking and control skills required to be part of the IIoT market? All right. So this is kind of a long answer. But I think it's important. I get this question a lot. What should I study? You know, I'm a grad student and I want to get into automation and IIoT. What do I do? So let me start with this. Systems integrators, IIoT engineers, automation engineers, controls engineers, they are born, they are not educated. Okay. But what I mean is, it doesn't mean they don't have educations. What I mean is, you don't create an automation engineer. You don't create an integrator. Those people are born. They are born thinking a certain way. The one thing that we all have in common, all the best engineers in the world that I've ever met in my life, they don't all have degrees in mechanical engineering or industrial engineering or electrical engineering. In fact, the absolute best engineer I ever met in my entire life has a degree in English. But he didn't get steered to engineering while he was in high school. He got a degree in the wrong discipline, but because he was born an engineer, he steered toward engineering later on in his career. Okay. The only thing that we all have in common is that we all want to know how everything works. We all tore apart our toys on Christmas morning. We wanted to know how they actually functioned. It was never good enough for us to just take on face value that I push this and this happens. Engineers are people who are born wanting to know what happens between this action and this reaction. Okay, so that's number one. You have to think a certain way to be good at this. You may not want to hear that. There are probably people on this call who don't want to hear that. But I assure you, the most successful engineers, especially in the IIoT space, their brains were wired a certain way when they were born. Okay, and you can't teach it. You can't teach that wiring. That being said, it's just like being able to jump 42 inches, having a 42-inch vertical leap. You're either born with the fast twitch muscle fibers to be able to do that, or you're not. I mean, I can't train anyone to jump 42 inches into the air from a dead stand. You can't do that, right? Okay, so that's the first piece. The first piece is you got to be born this way. The second piece is you have to be steered towards engineering as you're coming up, okay? I got lucky and got steered towards engineering, and I learned early on in my college career why it is that manufacturing left the United States. And so that, coupled with my engineering acumen, steered me towards automation. I decided a long, long time ago, I want my life to be about bringing good paying middle-class jobs back to the US. I'm going to do that as an automation engineer. And I know that's counterintuitive, but trust me, automation creates way more jobs than it eliminates. Creates way more jobs than it eliminates. And so I started out by saying, I'm going to become the best systems integrator on the planet. And I started that by getting a job in a salt mine. And I spent 5 years becoming a mechanic and a master journeyman electrician and an instrumentation and controls tech. So 6 years, really. I mastered that art. Then I said, okay, I need to learn all the processes. So how did I get exposure to PLC and DCS? I worked at different companies. So you got to do this too. If you're going to get exposure to DCS, you got to work at a company that uses DCS. And when you're in the job interview, you got to ask, do you guys use distributed control systems? Oh, you don't? I'm not going to come work here because I want to get that experience. So I left the mining industry. I had a great paying job working in mining, but great pay was not my focus. So then what I did was I moved to printing. So I went to a high-speed dirty process that used Profibus. The reason I picked printing was because they used DCS and they used high-speed field bus, which I didn't have any exposure on in mining. Okay. In mining, it was all Data Highway Plus, Rockwell, Ethernet. It was all super slow. I spent a couple of years there, and once I had learned everything I needed to learn, I switched. I moved to the steel industry. And in the steel industry, I got exposed to another type of DCS system. Plus, I got to do a bunch of TI conversion. One of the reasons I took that job was I was going to have an opportunity to do 2 major stacker conversions where I was going to be able to convert TI PLCs into ControlLogix automation. And it was all going to be done in-house with the Wonderware SCADA sitting on top of it. So that's part of the reason I took that job. But I also took it so I could do the DCS, the ABB DCS in steel. My last step was as an engineer in the automotive industry for a tier 1 automotive supplier. The reason I took that job, which came with a huge pay cut, my pay got cut in half because I went to automotive from steel. I worked for Nucor Steel, which I was making huge 6-figure numbers. My salary got cut in half to go work for this automotive supplier. But the reason I took that job was because they were also an OEM. They built their own manufacturing equipment in-house. And I wanted the experience of being a product engineer developing the actual equipment. Once I was done with that, it took about 12, 13 years of my career to do that. I switched to integration, and I went and worked for 2 of the best integrators on the planet. During that process is when I started studying machine learning and artificial intelligence. So I started studying machine learning and AI. At every step of the way, when I was in manufacturing, I would build things that no one asked me to build. So I would say, you know what this plant needs? It needs a plant level SCADA system. And I know they're not going to give me the money for it. So I'm going to go up and call my Wonderware rep, and I'm going to convince this guy to give me a free license. And I'm going to build this awesome thing, and I'm going to sell it to management, and then they're going to pay for it. And that's exactly what I did. And I did it over and over and over again, to the point where that Wonderware rep, who is based in Horsham, Pennsylvania, that guy, I'm here in Dallas, and we still work together to this day, 20 years later. So when I went to the integrators, I worked for 2 top-notch integrators. The first thing I learned was, what is it they do? How do they do this? And then I asked the question, how would I do it? Like, what jumps off the page at me as wrong about this approach? And then I went and created my own company. So to answer your question, what's the best way of learning network and controlling skills? You're not going to learn it in a classroom. The one thing every engineer is going to, that doesn't mean don't go to class. You need to take these classes. Go to Udemy and go get your Cisco certification. Go learn everything you can about MySQL and SQL Server. What I would recommend to you is join our mentorship program, and we'll train you. We'll give you all the skills you need to be successful. Now, everyone who joins our mentorship program better have been born with thinking the way we think, or you're going to be frustrated. Okay. But in the IIoT market, there is no one out here teaching this stuff. They're all using the words, but they all happen to not even know what the words mean. So, all right, Zach, did I answer that question?
Yeah, that was really good. I like that. I liked how that tied in with the arc of your career, led right into the next question. So what's the next question, Walker?
Discrete manufacturing versus process. So this was from Henry, and this was on the how to implement OEE in your manufacturing plant. He said, hey, this is a great video. However, it's really discrete manufacturing centric. How do you see the process manufacturing world where you produce stuff and not things, attribute driven, not part number driven? Okay, the answer is it's really no different. The difference is you're adding one additional piece to this, and that's generally batch management software, where you're tying the batch and lot number to it. It's an attribute to the manufacturing execution. So whether you're making widgets or whether you're making batches of stuff, the process is exactly the same. There's just one extra step, which is integrating batch management, which I didn't touch on in that video because the video would have ran too long. Okay. All right. The next question was, somebody had asked, hey, in the IIoT, the data hub explained, someone said, hey, can we use Kepserver as the data hub? The answer is no. Okay. And here's why. Kepserver wasn't designed to be a data hub. It's not that Kepserver can't talk to basically everything. It can, but it doesn't have a namespace. It doesn't have a namespace that is 100% accessible by other consumers in the ecosystem. So rather than using Kepserver, you would use another platform to be your unified namespace. And for us, it really more and more is looking like it's going to be a tool called HighByte. Okay. So for those of you who have not heard of HighByte, HighByte is Tony Payne, who was the former president of Kepware before PTC did the acquisition. He actually stayed on after PTC acquired. He broke off with a guy named John Harrington and created HighByte. HighByte is a tool for creating unified namespaces. Okay. He still has a very good working relationship with PTC. In fact, we were on the webinar for the new release of the HighByte software yesterday, and that was a joint effort between HighByte and PTC. HighByte basically gives you the only thing that the Intelligence Hub does. It's both edge-driven and centralized, so it can be, you can have many instances of the Intelligence Hub out on the edge. It is designed to create your unified namespace. Take that namespace, create and publish it to MQTT brokers, access it through OPC UA, you name it. HighByte is exactly the platform the solution we've been looking for as the standalone unified namespace. It is only in the 1.1 release. This is a really, really new platform. I think Tony and John started at the end of last year. We got to see it at the beginning of this year. We got to beta test the original release, and we're now testing the 1.1 release. Very, very slick software. It underneath the hood it's Node.js. Under the hood, that is the expression language is Node.js. It's very similar to, think of it as, I don't want to say it's similar to Node-RED, but there are some concepts about it in terms of the workflow that remind me a lot of Node-RED, but on steroids. Like HighByte is built to be a robust industrial platform. We've actually asked Tony and John to come on with Tori, who handles their marketing, to do our podcast. We're going to be doing some demos of the software. I absolutely love it. It's sick. HighByte does all the things that Kepserver can't do in order to be your data hub. Kepserver is a very powerful node in the ecosystem, but it is not capable of being your single source of truth for all producers and consumers of data and information in the organization, which is what you need with a unified namespace.
Wait, can you say that again? What is it? Why do you need the unified namespace?
All right. So what I would say is go watch the unified namespace video. But in a nutshell, the fundamental difference between Industry 4.0 and Industry 3.0 integration. Industry 3.0, it was nothing but a series of discrete connections between software platforms. I would connect my PLC to my OPC server. I would connect let me share this. I'd connect my PLC to my OPC server. I'd connect my OPC server to my different pieces of software. I would connect those pieces of software to, MES to ERP. I would connect ERP to other, okay? Doing that approach, the Industry 3.0 approach, is like, think of those software applications as a couch, right? You buy a couch in your house, or a bed, and you know that you are going to eventually throw that couch away and buy another one, okay? You're going to buy a new bed in 10 years and replace it. Doing it that way, the Industry 3.0 way, is like buying a new couch, putting it in your living room, and then building a wall on top of it. So that if you remove the couch, the wall comes crashing down. Okay, that's the Industry 3.0 way, right? The Industry 4.0 way is understanding that your data ecosystem, your information ecosystem, is the foundation of your business, okay? So the unified namespace is that foundation. So instead of the couch being underneath the data, what we do is we move it out here and we just plug it. We plugged the couch, the application, into the unified namespace. So my unified namespace is in the middle. It's that ISA 95 structure for all data and information in my organization, okay? It's that structure. The reason we love MQTT is because we can create that structure, report by exception from the outside in, right? We don't have to make discrete connections to make it happen. So I've got all these applications. They're all consuming information, data, creating information and putting that information back into the namespace, sometimes in a brand new place that's unique to that application, okay? A unified namespace means that I can unplug that application. I could put another application in its place that has the same purpose as the previous one did, and I can start consuming and producing back into the exact same place that the previous application used to do it. As opposed to doing these discrete connections from application to application to application. Think of the unified namespace as that big, it's not a data lake. Think of it as the organized structure of all business data that everyone reports and consumes from. One unified namespace. Excuse me, HighByte was built to be that. Ignition can be that. Factory Studio can be that. Standalone MQTT brokers, can be that, okay? All right, that was my last question. So did anybody ask any live questions?
Yeah, actually, someone asked, can you use any SCADA software as a data hub in IIoT?
The answer is no, you can't use any. You can use, so remember what our standards are for whether this is an IIoT software. It needs to be edge driven, needs to be report by exception, and it needs to be open architecture, right? Not all SCADA systems. And what does open architecture mean? Open architecture means is that software will play nice with basically anything. It'll talk to anything, okay? It allows you to access all of the data and information it creates externally, and you don't have to use any proprietary communication protocol to do it. I can use a database connection, I can use a REST endpoint, I can use OPC UA, I can use MQTT, I can use DMP3, you name it, right? The answer is no, not all SCADA systems will do that. They don't, not all SCADA platform developers care whether you can access that data. There are companies that care. Inductive automation is one of them. Remember where inductive automation came from. Inductive automation grew out of, we owe a huge debt to Steve Heckman and Colby Clegg and Carl Gold and Travis Cox and Vanessa Garcia, who all these original people at Inductive Automation who, Steve said, somebody said, hey man, you shouldn't use foul language all the time. Fuck that. All right. Steve Heckman said, fuck all these other companies who are screwing over manufacturers who won't build the solutions we want. We're going to build it ourselves. We're going to build exactly what it is customers need. Steve owned an integrator and he got sick of it. And he said, I'm going to hire a couple of guys out of UC Davis and I'm going to have them write me basically SQL tags. We're going to build our own SCADA system that does all the things that customers need. The reason he did that is because all SCADA systems didn't do what customers need. So the answer to your question is no, not all SCADA systems can do this. I want to use this video to not rant and rave about the companies that are really screwing people over. So I'm not going to drop the names on who you stay away from. You can watch our other videos to find out who those people are. Next question, Zach. You're on mute.
Yeah. That was good. And by the way, this video is not sponsored by HighByte. We just share the information that we use.
Correct. In fact, none of our videos are sponsored by anyone. And in fact, inductive automation, a lot of people will say, hey, you're an inductive automation Kool-Aid drinker or whatever. No, I'm telling you the truth here. You'll find lots of people at inductive automation who will say they don't like me and that I'm rough around the edges. Because even when inductive automation screws up, I yell at them too.
All right, so I'm going through the chat here. And if you guys do have any questions, we're going to try to wrap this up around the top of the hour here, depending on where you're at. So we got about 20 more minutes. So ask the questions now and we'll go ahead and answer them. Yeah, so someone said, please tell me IIoT software, which one you're using now. And we kind of really just talked about that. Who are the key, this one's good. Who are the key decision makers you speak with at organizations to green light an IIoT project?
Outstanding question. So I think what I'm going to do is touch on that the politic part, okay, in this answer. So I would say in general, there are basically two ways that we get introduced to customers. the three ways really. Either they reach out to us because of our reputation. We reach out to them. Guys like Vaughn and John are looking for people who need our help. Generally, we're targeting the customers that we know if they don't make a change, they're going to be obsolete. So we're generally targeting them. These are people generally.
People don't like to hear that though.
Well, if they don't like to hear it, then we don't work with them. And if Vaughn will tell you, we just had this call. We just had this discussion yesterday. And I'll talk about it in a second. Or they are referred to us by another client, a vendor, a strategic partner. Okay. Most of the time, the person that we're talking to now is their IIoT guru. Most companies at this point, especially now, come end of July 2020, they have all created digital transformation boards. They've all steering committees. They've all created IIoT gurus, and many of them started doing it in March. Okay, so literally they're freaking out. There are you want to talk about the economic impact of this pandemic? There are, we're at 1 million small businesses have closed in the United States. That's by the way is like 13 years of business creation. It takes 13 years to create 1 million businesses. 13 years of business creation has evaporated since March. Okay, 1 million businesses have closed. You have manufacturers all over the globe that are going to go under. Okay, all over the globe. We won't see any of the real bad numbers until Q1. So Q1 is when you're going to start seeing the devastating reports. By the way, today, Reuters just reported this morning that the actual economic GDP contraction for Q2 was 32%. We ran our models that we wrote, which by the way is unprecedented, 5 times greater than any bigger any other previous contraction. We've been running linear regressions to do that analysis, and we projected 36%. So that's how close machine learning came to predicting what the actual contraction was. And our numbers were calculated in the beginning of April. So we knew that the Q2 contraction was going to be, we thought it was going to be 36% when we ran the machine learning, we ran linear regressions, and it ended up being 36, it ended up being 32. What's happening is right now we're talking to the IIoT guru because every company is now creating them. Okay, so it doesn't matter whether you're talking about our biggest pharmaceutical company, our biggest food and bev company, they have some digital transformation manager. Okay, prior to that, most of the time we were talking to like the corporate director of engineering or an engineer, a process engineer or a production engineer in one of their plants who had a vision. The short answer is you have to be prepared to talk to lots of different people. But what's most important here, this is the most important thing. When you are talking about IIoT, you're not selling IIoT. Okay? What you are doing is you are educating the customer on IIoT. You are telling the customer, you're not going to be in business if you don't do this. And we use Amazon and Tesla, and we use all of I use the phone analogy all the time. I say, there are manufacturers out there. In fact, we're working with one right now, a brand new company that is going to compete with some big boys. They've hired our company to digitally transform them before they even put the first shovel in the ground, building their new facility. They're building a state-of-the-art manufacturing facility that is literally going to crush the competition, crush their competition.
Like how Amazon crushes the competition.
Absolutely. Yep. And I can tell you one other thing. The other thing that you need to do is when you go into these conversations, you need to find out if the client is right for you. I tell my team this all the time. We don't want to get bogged down with a customer who's not right for us because it keeps us from helping other people. We have to decide, are these guys going to be in business or are they going under? Are internal politics going to kill them or are they going to overcome them? We ask those questions, and you have to ask those questions too. Okay.
So we have a couple good questions. I'll let you decide. So there's two. Well, you could answer both of them if you want. One is from Pokes. Giza said, in one of your videos, you talked about being a world-class engineer. How do you define world-class engineer?
World-class engineer is a person who has a a proven track record of snatching victory from the jaws of defeat. That is a world-class engineer. Okay. You don't define, like you don't get to decide whether you're a world-class engineer. I'm a world-class engineer because within our space, my reputation is I'm the guy who can snatch victory from the jaws of defeat. And I'm not the only one. There are lots of engineers out who have those reputations. You know those people. Okay. One of the questions we ask our engineers is, can you be given a stack of papers that is nothing but a bunch of ideas and deliver on the spirit of those ideas and be the guy that made that happen? Can you do that, or be the girl that made that happen? That is a world-class engineer.
Awesome. All right. So then the next one is from D Longoria 59. What are the top 3 reasons small to medium sized manufacturers are attracted to IIoT, Industry 4.0, and digital transformation? And what percentage of those companies are making this move? Why are the top 3 reasons that small to medium sized manufacturers are attracted to IIoT, Industry 4.0, and digital transformation?
Perfect. That's an outstanding question. The answer is the number one reason above all else is they've plateaued. So how does a small company become a medium company? How does a medium company become a huge company, right? The answer is they figure out a way. I mean, our businesses don't scale infinitely. They scale. What happens is they scale to a point, we hit a ceiling, we hit a glass ceiling, and we don't know how to get past it. So the number one reason is they've hit a ceiling. They know they've got. Go ahead.
People do this in life too, I think, but go on.
Yeah. So they hit a ceiling. They ask all the pertinent questions. Do we have the right equipment? Do we have the right business model? Do we have the right staff? And they answer yes. I've got the right business model. We got the right clients. We're in the right market. But what they get to is, do we have the right technology? And they say no, we don't. And so that's number one. Number one is they've plateaued and they're trying to figure out how to overcome that barrier. So that's number one. They need the technology. Number two, they're visionaries. Most of the time, if you're a medium-sized company, you are not 100 years old. Okay. Generally, when you're a medium-sized company and you're still in business, you probably started within the last 20 to 30 years. If you're a small company and you're still in business, you probably started within the last 5 to 10. So what's happened is they're visionaries. So number two is they're never satisfied with doing $5 million in revenue a year or 10 million or 50 million. What they're saying is, I want to be Amazon. I want to be the go-to. We have a client who makes packaging, food and beverage packaging for chips. The guy who runs that company bought that company. It was a bankrupt company. He bought it after he retired from a major manufacturer as an executive in Europe, came back to the States and bought the company for like his family. And he said, I'm going to turn this company around. He did turn it around. And over the course of 10 years, he turned it into a highly profitable business that could do short runs of packaging, unlike anyone else in the industry. But then he hit a glass ceiling. And he said, what's missing? And the answer was technology. And so what he said was, I'm not satisfied having just this one manufacturing facility with 20 machines. I want the one in Houston. I want the one all over the United States. And he said, in order for me to be able to do that, I got to connect everything together. So that's number two. And number three, it's just pure curiosity. I think most people look at their phones and think about it, man. The first iPhone came out in 08, right? Was it 08? Smartphones.
07, 08, yeah.
07, let's say 08. Smartphones have existed for 12 years. 12 years. And most people, when you tell them that smartphones didn't exist 12 years ago, can't believe it hasn't been longer. And so when you're running businesses and you have a smartphone that's got all of human knowledge at your fingertips, your whole life is in here, it's really hard for you to live with the fact that the production report I get tomorrow morning is the earliest I'm going to be able to see the data about how I produce today. It's really hard for you to live with that. It's hard for you. And so you say, I'm curious, is there something out there? Can I be the first one to change it? Sorry, hopefully that wasn't too long.
Oh, what percent? Yeah, the last little bit of that was what percentage of companies in that space are making that transition?
Every one of them. Right, I can tell you right now, we are not finding a single company at this point who is saying they don't want to digitally transform. In fact, most of them are scared shitless. You can hear their voices cracking, and that's not metaphorical. That's you can hear their voices cracking. Every single company, I'm telling you right now, you will not find a single manufacturer on the planet right now who doesn't think they need to digitally transform. And that all happened since March. Before that, I would say the number was somewhere between 10 and 30%.
Okay, sweet. All right. So I have one here from John Fox, looking for your commercial opinion of speaking IT/OT to an audience that doesn't understand that a network or HMI outage has no effect on the PLC running its process. Oh, this is like the cloud application one.
Okay.
Almost.
So, all right. So here's my recommendation. Number one, don't use the terms IT and OT. Okay. And here's why. When Arlen Nipper started using IT and OT a couple of years ago, he was saying the convergence of IT and OT. He was not using that term thinking it was going to become a marketing slogan. Okay. And so it meant something. He was saying, hey, there's pieces. So when you say IT and OT, no one knows what the hell you're talking about. Okay. Why don't you say the stuff that the IT department controls and the stuff that happens on the plant floor? Because that's more effective. People understand that. Your machines, connecting your machines to your business. That's another good way of describing it. Okay. When you say IT and OT convergence, what happens is people's eyes glaze over now. When you say digital transformation, their eyes glaze over. When you say Industry 4.0, their eyes they roll their eyes. Oh, we've heard this one before too. You know, number one, what was the second part of the question?
Well, he's saying, how do you explain to someone that it doesn't matter that the HMI disconnects from the PLC running its process? How would you explain that to someone, that PLC and HMI connection?
Yeah, I wouldn't. What I would say is I wouldn't even explain it. That's not something I would get to that, because I'm not going to explain that I've got two separate programs, one running in the HMI and one running inside of the PLC, or one running in the SCADA system and one running, and they're independent of one another, because they're not always independent of one another. Sometimes you have an idiot who writes logic, PLC logic inside the SCADA system, that if you do disconnect the SCADA system from the PLC, the process will stop running. Sometimes you end up with that, but I generally wouldn't explain that. This is the reason
he followed up with some additional information. He said a network outage occurred and a PLC continued to run the process as designed, but a QA error resulted in a product contamination. We are the controls integrator. Help explain this to C-suite at the plant. So it sounds like the QA department was dependent on data that it then lost information to, but the PLC ran its process, resulted in a product contamination. They're the controls integrator for that plant, and they're talking to their customer, the C-suite, explaining what went wrong.
What you say is that there are, this is what I would say. I would say we're in the business of making mistakes and recovering quickly, and you should be too. Okay. A mistake that you made was you never asked the question, what happens if the network goes out? Okay. Here's what happens. If you have a QC critical application running in the HMI, and that HMI is connected through an Ethernet cable to the PLC, and that PLC is connected to the process through field wiring. Okay. The way that the PLC fails running the process is by cutting the wires. Okay. You got to go in and physically cut the field IO, right? The way that the HMI in the PLC fails is by having a network outage. One of the things that we do when we develop our applications, we actually go PLC, HMI, SCADA, MES, ERP. We show the layers, and then we show the roles and responsibilities and the criticality at each layer. That is, what is the uptime? So when we write a PLC program, we show that a PLC we expect it to have 5 nines of uptime in a year. We show that the HMI is expected to have 3 or 4 nines of uptime every year. The SCADA system is supposed to have 1 9 of uptime throughout the year. The MES system is going to have 1 9 of uptime. We show that. we show those uptime numbers so that they are aware that if you put a QC critical element in this layer, then you have to expect 18 minutes of outage per year. And then they can say, okay, well, that needs to run on the edge. I want to say this. PLC, a lot more can run on the edge today because the processors that run in PLCs are much more powerful. You can store alarms for years if you want to. The things that are absolutely process critical need to live on the edge. They got to live on the edge. So that means don't connect the HMI to the PLC through a common network switch. You physically connect it to the PLC so it can't, a network outage doesn't impact it. But that's part of the engineering design. Those are considered questions you have to ask while you're designing the system.
Oh, awesome. Great question. That one was from John Fox, right?
Yeah, I was unclear on that. I wasn't clear on the
first and question. Sonia Scriven added a nice comment. This is why you need to have all stakeholders at the start of the project.
So that's spoken like a true project manager right there. Sonia, nicely done. So this is one of the biggest problems. This is a very good point, Sonia. One of the biggest problems that I have seen during system development, whether that you're building machines, whether you're building a plant, whether you're building a campus of plants. One of the biggest problems I've seen is during the initial design phases, the correct people are not in the room. How often, all these controls engineers here, how many times are you part of the discussions before a machine is built so that you can ask the question, hey, do you have a state register in your PLC code hey, machine builder, when you build this, are you going to include a state register? Are you going to include a lifetime counter? Are you going to include state by cell? Those questions never get asked. So when someone wants an MES system, one of the very first steps, one of the first things you've got to do is put those in. And if all the stakeholders were part of the initial discussions, you would have a lot of the groundwork, a lot of the framework you need to develop IIoT solutions without having to go back and integrate them.
Awesome. And guys, there's more questions that you've asked, but we're running out of time here. We want to be respectful.
Let's answer one more.
Okay.
One more question.
So it's 9:59. Let's see. If you guys have any last minute questions, drop them down below. We're going to answer one more question and then we're going to end it. And we're going to do this again next.
I do want to know if everyone thinks this is valuable.
Okay. Yeah. Let us know if you think this is valuable. All right. Last one from Grish. Mahashre. Sorry if I messed that up. I'm just going to say Grish. Which system would you recommend for IoT when you have to store data locally when internet doesn't work? And as soon as the cloud is connected, it transfers all the data to the cloud?
Great, outstanding question. The answer is there isn't one specific system. Well, let's say I wanted to, but to give you an answer, if I am going to, if what I want is but basically what you're looking at is edge buffering. So I need a layer in the ecosystem that's going to buffer that data on the edge, and once it reconnects, send it back up. There's no question that the best solution on the market right now is Ignition Edge and Ignition. So your architecture would be Inductive Automation's Ignition Edge on the edge and Ignition. A very, very close second is Factory Studio's solution. So Factory Studio also provides that same level of edge cloud reconciliation is what you're looking for, okay? But it's going to be Ignition Edge running on the edge, and it's going to be Ignition in the cloud. Now, one of the projects I talked about earlier that we've developed from the ground up for an oil and gas supplier, we actually built a custom solution. So we actually wrote our own MQTT transmitter that's running inside of an edge PC that does all that buffering for us, all that store and forward for us, and there's no Ignition Edge running there. So there are lots of solutions out there. By the way, the Intelligence Hub by HighByte is going to be one of them. Kep Server is one of them. There's lots of them, but the best one right now, in my opinion, is Ignition Edge and Ignition with Factory Studio a close second.
I'm just going to add this on because Grish also asked this question, which was you always talk about Ignition. He's familiar with WinCC. He didn't specify whether it was WinCC OA or WinCC 7, but he said, what functionally can you do in Ignition that you can't do in WinCC?
Oh, well, let's talk. Well, there's a lot you can do.
Maybe that's another video for another day.
It's a whole other video. What I'll say is this: I'm a huge fan of WinCC OA. I generally only use WinCC for HMI development that's going to run on a panel inside of a machine, on a machine. I'm not going to use WinCC as I'm not going to use it as my SCADA system, and I'm certainly not going to use it as my unified namespace. But I would use WinCC OA for a unified namespace and my centralized SCADA system. OA is the WinCC offering that is commensurate with Ignition and Factory Studio and those.
Awesome.
Yep.
Well, that's going to be it for this episode of the community live stream. Guys, keep a lookout for the link to the community Discord server. So that's just going to make it a little bit easier to get updates on when we go live, and just a more centralized place to keep the community engaged and involved. So keep an eye out for that. Walker, any last notes?
This was fun. I do want to have feedback from everyone in terms of, was this valuable? Was it a complete waste of time? Was it too long? Was it not long enough? Did I answer the questions too in depth, not in depth? I mean, at the end of the day, we're trying to educate the community. We're trying to be a resource. That's our whole goal. And so we're not a resource unless we're doing it the way you need us to do it.
That's it. Thank you, guys. We'll see you guys next time. Peace.
Appreciate y'all.
All right, let's